So in continuation, let's do some question based on this chapter, atoms and molecules, right? So in this question number 1, calculate the molecular mass of nitric acid, right? So nitric acid is HNO3. What is the chemical formula of nitric acid? It is HNO3, right? Okay, so now we have to find the molecular mass. So molecular mass of HNO3, this is equal to the atomic mass of hydrogen, right? Atomic mass of hydrogen plus atomic mass of nitrogen. Atomic mass of nitrogen plus atomic mass of, since there are 3 atoms of oxygen, right, in HNO3, what are the constituent elements? Hydrogen, nitrogen, and oxygen, right? So one atom is for hydrogen and nitrogen, but there are 3 atoms of oxygen, right? So what we will write here, plus 3 into atomic mass of oxygen. Getting that? Right? Now for this, you should also remember what are the atomic masses of hydrogen, nitrogen, oxygen, right? Okay. So atomic mass of hydrogen is 1. So we'll write it 1 plus atomic mass of nitrogen is 14. Okay. And atomic mass of oxygen is 16, right? So this will be 3 and 16, right? Because there are 3 oxygen atoms. So 3 into 16. So now it will become 1 plus 14 plus 48, right? This is equal to 63U. 63U or 63 AMU, atomic mass unit. Both are same, right? So what is the molecular mass of HNO3? That is 63U, right? And how we have to find this? We will simply add the atomic masses of individual atoms of different elements, right? So there are 4 atoms, 1 hydrogen atom, 1 nitrogen atom, and 3 oxygen atom, right? So we simply put their values, right? And we add them to get the molecular mass of nitric acid. Is that clear? Please write down. So look at this question. Question number 3, calculate the molecular mass of C2H6 and CH3OH. C2H6 is ethane, CH3OH is methyl alcohol or ethanol, methanol, right? Okay, so molecular mass of C2H6 is equals to 2 into atomic mass of carbon, because there are 2 atoms of carbon here, right? Atomic mass of carbon plus 6 into atomic mass of hydrogen, because there are 6 hydrogen atoms, right? Atomic mass of hydrogen, right? Okay, so for this we should know what are the atomic masses of these elements, right? So atomic mass of carbon is 12, so 2 into 12 plus atomic mass of hydrogen is 1, so 6 into 1, right? Now calculate this. 24 plus 6, that is 30 U, right? So what is the molecular mass of C2H6? That is ethane. It is 30 U. Is that clear? Is or no? Yeah. So now we have to find the molecular mass of CH3OH, methanol, right? So what we do? We will simply add the atomic masses of all the atoms present in this molecule, right? So as you can see here, we have 1 carbon atom, right? Okay. Then 3 hydrogen atom, 1 oxygen atom, and 1 hydrogen atom, right? So how many total hydrogen atoms are there? 3 this and 1 this, 4. Total 4 hydrogen atom, right? 1 carbon atom and 1 oxygen atom. Getting that? So now what we will write here? Atomic mass of carbon plus 4 into atomic mass of hydrogen, because there are 4 hydrogen atoms, plus 1 into atomic mass of oxygen, right? Because there is only 1 oxygen atom, right? So atomic mass of carbon atomic mass is 12, okay? Plus 4 into atomic mass of hydrogen. We know that atomic mass of hydrogen is 1. So 4 into 1 plus 1 into atomic mass of oxygen. So this will be, oxygen is 16, right? Okay, so now we can add this. 12 plus 4 plus 16, that is 32, right? And what will be the unit? It is U or AMU. So a molecular mass of CH3OH is 32 U. Is that clear? Right? 32 AMU, atomic mass unit. Okay, so we simply add the atomic masses of the different atoms in that molecule of methanol. Is that clear? Okay, so this is the answer. Yes, Alish. Now look at this question, question number 4. Hydrogen and oxygen combine in the ratio of 1:8 by mass to form water. Okay, what mass of oxygen gas would be required to react completely with 3 gram of hydrogen gas? Right, so now we have to find like how much oxygen gas is required to react with 3 gram of hydrogen gas. Okay, now since hydrogen and oxygen combines in the ratio 1:8 by mass, it is already given, right? Okay, that means hydrogen is to oxygen, this ratio is 1:8 by mass. This is already given, right? That means what? Mass of hydrogen upon mass of oxygen. This is equal to 1/8. This is the meaning of this ratio. Ratio by mass means their ratios is 1/8, right? Now let the mass of oxygen, required to react completely with 3 gram of hydrogen gas is suppose X, right? We have taken X is the mass of the oxygen which is required to react completely with 3 gram of hydrogen gas, right? So now what is the ratio? Now mass of hydrogen upon mass of oxygen. So let's find out. It is 3. So when hydrogen gas is 3 gram, oxygen gas will be X gram, right? So 3 upon X, and this should be equal to the ratio 1:8 means 1/8. So this should be equal to 1/8, right? So from here we can find the value of X, right? So X is equals to 3 into 8 gram, right? That is X is 24 gram, right? So therefore 24 gram of oxygen is required to react with 3 gram of hydrogen to form water. 3 gram of hydrogen to form water, right? Because this ratio will always be same. Ratio by mass 1:8 is always remain same, right? So if hydrogen is 3 gram, then what will be the mass of oxygen which will react with this 3 gram? That is 8 times of the mass of the hydrogen, right? That is 24. Then only the ratio will become 1:8. Is that clear? Right? So in this way, we can find out what will be the mass of the oxygen which is required to react with 3 gram of hydrogen to form the water. So I hope you have understood this. Yes or no? Okay. So this ratio by mass, which is fixed, this comes from the law of conservation of mass, right? In a constant proportion, right? Okay. Law of constant proportion, right? So whenever a compound is formed, the atoms of different elements, they are combining together but in a fixed ratio, right? And that ratio will always remain same. Is that clear? So the ratio by mass of hydrogen and oxygen in water is 1:8, and it will remain same always, right? So wherever from you are taking the sample of the water, the ratio of their masses will always remain 1:8, right? So using this constant ratio, we can find out like what will be the mass of the oxygen which will react with 3 gram of hydrogen.